The weight W of basketball players in a tournament is found to be normally distributed with a mean of 65 kilogram and a standard deviation of 5 kilogram. Find the probability that a basketball player has a weight that is more than 61 kilogram and sketch a diagram of a normal distribution shading the region representing this probability. We are given X follows normal distribution with a mean 65 and a standard deviation 5. We are looking for probability of X greater than 61. Go to normal CDF. Menu 55. 2. Lower bound 61. Upper bound. Go to pi. Infinity. Mean 65. Standard deviation 5. Enter, enter. Answer is 0.788. Let's sketch a diagram to show these probabilities. 65 as the mean. Standard deviation is 5. This is 60. Let's sketch a bell-shaped curve greater than 61. Label, this is 61. Then shade this area. This is the probability of X greater than 61. B. In a training session, there are 40 basketball players. Find the expected number of players with a weight less than 61 kilogram in this training session. Probability of X less than 61 equals. We already figured out in A, probability of X greater than 61 equals 0.788. So we will use this formula. 1 minus 0.788 equals 0.212. We are looking for expected number. Expected number equals n times probability, which means 40 times 0.212 equals 8.48. C. The probability that a basketball player has a weight that is within 1.5 standard deviation of the mean is Q. Sketch a normal distribution to represent this probability. 1.5 standard deviation equals 7.5. 65 plus 7.5 equals 72.5. 65 minus 7.5 equals 57.5. Let's sketch this graph. Mean 65. 1, 2, 3. 1, 2, 3. The distance between any two labels is standard deviation 5. Sketch this bell-shaped curve. 60, 55, 57.5 will be in the middle. 70, 75, 72.5 is here. Then shade the area between 57.5 and 72.5. D. Find the value of Q. We are given probability of X greater than 57.5, less than 72.5 equals. We will use normal CDF. Manual 552 57.5 72.5 mean 65 standard deviation 5 enter 0.866 so Q equals 0.866. Let's go to E. The probability that a basketball player has a weight that is more than K is 0.225. Sketch a normal curve to represent this probability. Mean 65. Let's sketch this bell-shaped curve. We are given probability of X greater than K equals 0.225. We know probability of X greater than 65 equals 0.5, which means K is on the right side of 65. We just say this is a K. This is the area, 0.225. Find the value of K. We are given probability of X greater than K equals 0.225. We have to use inverse normal to work out this K. For the area, probability of X less than K, which means 1 minus 0.225, which is 0.775. Manual 553 0.775. Mean 65, standard deviation 5. Enter. Answer is 68.8. K equals 68.8. F. Estimate the interquartile range of the distribution. We know these facts about normal distribution. Probability of X less than first quartile equals 0.25. Probability of X less than the third quartile is 0.75. So probability of X less than Q1 equals 0.25. The area equals 0.25. Let's go to inverse normal. Manual 553 0.25. Mean 65, standard deviation 5. Enter. Answer is 61.6. Probability of X less than Q3 equals 0.75, which means area equals 0.75. We will use inverse normal. Work out this Q3. Go up. Enter. Change 0.25 into 0.75. Enter. Answer is 68.4. So interquartile range equals Q3 minus Q1 equals 68.4 minus 61.6 equals 6.8.